In this video, we're going to quickly learn by example how to use the inverse t function in the TI-84. So for each of these problems, we'll be given an area under the t distribution, and we want to calculate the critical value of t that bounds that area. So we're going to work through three types of examples, and those are left tails, right tails, and central probability regions. So in the first example, we're given a left tail probability of 0.10, in other words, 10%. And we're told this t-distribution has 13 degrees of freedom. In other words, it came from a sample size of 14. So in our calculator, we press second and then vars. That gets us to our statistical distributions. We go down to inverse t, and we enter the probability to the left of the cut line, which is just 0.10. And we were already told this t-distribution had 13 degrees of freedom, so there's that. Enter and enter. And we get t equals negative 1.35. So our cut line bounding the lowest 10% of the distribution is negative 1.35. In our second example, we're given a right tail probability of 0.20. And again, we're working with 13 degrees of freedom, and this time we have to do a little preliminary work. The inverse t function expects us to enter probability to the left of the cut line rather than the right. So we have to do a quick calculation. So the area to the left of the cut line is just 1 minus 0.2, and that gives us 0.8. So that's the value we're going to use for inverse t. So we press second and then vars to get to our statistical distributions again. We hit inverse t, and this time we put in an area of 0.8. The degrees of freedom is already in there, and we go ahead and paste that. And when we run the numbers, we find that t is 0.87. So 0.87 is the critical value bounding the upper 20% of the distribution. Now in our third and final example, we're asked to find the t-scores bounding the middle 95% of the distribution. In other words, there's a probability of 0.95 there. And again, we're using 13 degrees of freedom. So again, we have to find the probability to the left of each of these cut lines, T1 and T2. And with the central 95% shaded, that means 5% of the distribution is split between the tails. So we take that 5% and divide it by 2, and we find 0.025 is the probability in each tail. Well, that means the area to the left of T1 is just 0.025. So we go to our t distribution, and we enter a probability of 0.025 to the left of T1, and we find a t-score there of negative 2.16. Now we could argue that the other t value is just positive 2.16 by symmetry, but just to show the math, we can find the area to the left of T2 by taking 1 minus the area above T2. So 1 minus 0.025, and that gives us 0.975 or 97.5% of the distribution to the left of T2. We head back to our t distribution, put in an area of 0.975, and it came out like we expected. It turns out to be positive 2.16. In the next video, we turn this procedure around and calculate probabilities based on known t-scores. I'll post a link to that video at the upper left when it's done, and I'll see you there.